we are going to study about structure of atom, that is chapter 4 in class 9. In this chapter we are going to deal with different subatomic particles which are present in an atom. Atoms have three types of subatomic particles which are electrons, protons and neutrons. Electrons are the smallest as they have negative charge. Protons are heavier than electrons with positive charge. Neutrons are heaviest and have no charge on them. The mass of electron is 1 by 1826 of the mass of proton. The mass of proton is nearly equal to the mass of hydrogen atom and is taken as 1 unit. The mass of neutron is slightly more than mass of proton. Electron was the first subatomic particle discovered, and that was followed by discovery of proton and neutron. Charge on an electron is equal to charge on a proton, although opposite in nature. Hydrogen is the only known element that do not have neutron in it. So hydrogen is an element without neutron. Now the discovery of different subatomic particles. First is the discovery of electron. J.J. Thomson discovered the presence of negatively charged particles called electrons in an atom. A simple experiment which was conducted by him is called cathode ray tube experiment. Cathode ray tube is a glass tube which is partially evacuated, that is, much of the air was pumped out of the tube. Cathode ray tube was initially designed by Hittorf. He observed that on applying voltage to a stream of particles was emitted from the negatively charged electrode, that is cathode, and these positively charged particles move towards anode. These particles, the negatively charged particles, were emitted from cathode and they move towards anode. Cathode ray tube used by Thomson was slightly different from others. These rays were named as cathode rays by Goldstein as they are emitted or produced from cathode, and the whole construction is called as cathode ray tube. Now let us see, here is the cathode ray tube shown to us, how the discovery of subatomic particle electron was made. We have taken a cathode ray tube, we have taken a discharge tube which is fitted with cathode and anode, which are connected to the two different terminals of the battery, and then there is a vacuum pump to drive out air from this discharge tube. We have filled the discharge tube with air at very low pressure, and when we apply high voltage of the order of 10,000 volt, we are able to see that a green glow is produced in this discharge tube. And what we observe, that these are the rays which are traveling from cathode towards anode, and they are seen in the form of green glow in a discharge tube, which actually led to the discovery of the rays, and thus hence since these rays were emitted from cathode and they were moving towards anode, we say that these rays are made up of subatomic particles called electrons which are negatively charged, and hence these rays are attracted towards positive anode. When experimentally studied, cathode rays showed the following properties. They travel in straight lines as shown in this figure. They are deflected by electric field as they carry charge. Cathode rays are deflected by positively charged plate and thus consist of negatively charged particles which were actually called as electrons. Cathode rays are also deflected by magnetic field. Cathode rays show particle nature. They are independent of the material composition of the cathode. That is, similar properties for cathode rays were observed irrespective of the material of cathode and the gas filled in the discharge tube. Discovery of protons, that is the other subatomic particles which were discovered after electron. E. Goldstein performed the experiment using perforated cathode and discovered these new radiations in a gas discharge tube behind perforated cathode. These radiations were named anode rays as they are emitted by anode. Goldstein called these positive rays as channel rays or canal rays as they appear to be produced by the holes or channels in the cathode. These rays later led to the discovery of the positively charged protons in the atom. Various properties of canal rays are as follows. They are deflected by electric and magnetic fields. Their deflection is opposite to that of cathode rays. They also travel in straight lines. The velocity of canal rays is much smaller than the velocity of cathode rays. Mass of the canal rays vary or change with gas used in the experiment. In 1932, Chadwick discovered the presence of particles having no charge in the atom, and these were called neutrons. So, discovery of electron is followed by discovery of protons and then further by discovery of neutrons. Now, this is the discharge tube shown where we have actually come across the discovery of protons. In this discharge tube, you see the alteration. The cathode which we have used here is perforated or has channels or holes in it, so that the rays, positive rays from the anode can pass through it, and these positive rays which pass through the anode are observed as a red glow behind cathode. And since this red glow is seen behind the cathode, it means the rays which were produced from anode has passed through the cathode, that is, they were attracted towards the cathode, and hence we came to know that they were the positively charged rays and hence are made of protons. Now we will come across the different structure of atoms which were proposed by different scientists at different times and how this helped us in further strengthening the subatomic particle discovery. Now the very first model which we are dealing with is Thomson's model of atom. This Thomson model of atom actually stated atom as a Christmas pudding, and this is also popularly called as plum and pudding model. The pudding has positive charge and the electrons having negative charge were like plums in the pudding. Thomson proposed that atom consists of positively charged sphere and the electrons are embedded in it. And he also stated that negative and positive charges are equal in magnitude, so the atom as a whole is electrically neutral. This model has a limitation. That was, this model was not able to explain the observations made by Rutherford later in the gold foil experiment. This model can also be compared with the watermelon. The red part of the watermelon can be considered as a positive sphere in which the seeds are embedded like electron. Then further, after Thomson's model came the next model, that is the Rutherford model of atom, which is popularly called as Rutherford alpha particle scattering experiment. Rutherford proposed that whenever we pass highly energetic alpha particles through gold foil, through a very thin gold foil, we see that the alpha particles pass through gold foil and we see three types of rays moving across. In this diagram, we have been shown the foil, gold foil, which is surrounded by a photographic sheet to observe the path of alpha particles. If we see carefully this diagram, we are able to observe that most of the particles are passing straight through the gold foil, and there were some particles which actually get deflected by small angles, and there were some alpha particles which actually revert back. So from Rutherford's observations, Rutherford's experiment, the following observations were made. It was observed that more than 99% of the alpha particles passed straight through the gold foil. Just less than 1% of the alpha particles were slightly deflected by small angles, and very few, 1 out of 2000 of all alpha particles, appeared to rebound or revert on their original path. Now, from these observations, we came across following conclusions about the structure of atom, and besides that, we are able to provide with a model of atom with the following observations. From Rutherford's experiment, we concluded that as most of the alpha particles were passing straight through the gold foil, it is an indication that most of the space inside atom is empty. As we say, less than 1% particles were deflected by small angles. The atom must have a small nucleus with a positive charge, which produces repulsive forces for alpha particles, as alpha particles were also positively charged and the nucleus is also having positive charge, so there are forces of repulsion created. Small number of particles, that is 1 out of 12,000 particles, rebound due to strong repulsive forces experienced from the nucleus, and this states that the size of the nucleus is very small as compared to the size of the atom. From the following conclusions made, Rutherford stated the model of atom, and the important postulates of his model are as follows. Atom is a positively charged nucleus at its center, and most of the mass of the atom is concentrated in the nucleus. The electrons revolve around the nucleus in circular orbits. The size of the nucleus is very small as compared to the size of the atom. Now, the limitations or the demerits which were associated with Rutherford's model are as follows. According to Maxwell's rule, any particle in a circular orbit would undergo acceleration and would radiate energy. So the revolving electrons would lose energy and fall into the nucleus, and thus atom would be unstable. No information was conveyed about the distribution of electron in orbits as given. So he could not actually explain the stability of an atom. Thank you.